So this question says, determine the values for A for which the system has no solutions, exactly one solution, and infinitely many solutions. And then we are given 3 equations. Now the first thing you should always think to do is to write this out into an augmented matrix. So here we have 1, 1, 7, and augmented because we're going to include the answers, -7, and then 2, 3, 17, -16, then 1, 2, a squared plus 1, and we have 3a. So now we're just going to treat this like any other system of linear equation and go ahead with our Gauss-Jordan elimination. So we start here. This is a 1. Now what we're going to do is we are going to zero out this entire column, meaning everything under it, and we're going to make it zeros. So let's see. Let's start with row 2. Our new row 2 is going to be our old row 2 minus 2 times row 1. So 2 minus 2 is 0. Let's just do 2 things at a time to make this a little bit quicker. So our new row 3 is equal to our old row 3 minus row 1, because 1 minus 1 is 0. Now if we just take this out, write it here, make it a little bit bigger, row 1 stays the same. And now row 2 is row 2 minus 2 row 1. 2 minus 2 is 0. 3 minus 2 is 1. 17 minus 14 is 3. 17 minus 14 is 3. -16 minus -14 is equal to -2. And here we have 1 minus 1, which is 0. 2 minus 1, which is 1. A squared plus 1 minus 7 is just a squared minus 6. 3a minus -7 is 3a plus 7. I'm going to have to make this bigger next time. So we did the first column, and we're going to move on to the second one. Second leading one is this one here, and we are going to zero out the top and the bottom. Let's just start with the top. So to do that, we're just going to do our new row 1 is equal to our old row 1 minus row 2, because remember we want this to be a 0 and this to be a 0, and 1 minus 1 is equal to 0. So we're going to write that out here. We have 1 minus 0, which is equal to 1. 1 minus 1 is 0. Then we have 7 minus 3, which is 4. Minus 7 minus -2 is -5. And while we're at it, let's just zero out this one as well. Here, 1 minus 1 is also 0. So our new row 3 is equal to our old row 3 minus row 2. Row 2 does not change. It's 0, 1, 3, -2. Then here we have 0 minus 0, which is 0. 1 minus 1 is 0. A squared minus 6 minus 3 is a squared minus 9. Then 3a plus 7 minus -2 is 3a plus 9. Alright, so this is what we have. Now we can go ahead and solve for one solution, no solutions, and infinite amount of solutions. If you remember, if something has no solutions, it means that these 3 numbers here are 0, and this number is not 0, because 0 times something cannot equal something that's not 0. So let's see. 1 is a squared minus 9 equal to 0. Well, plus 9 on this side, plus 9 on this side. We get 1 is a squared equal to 9. Well, a squared is equal to 9 at plus or minus 3. Now it's super important here to look at the other side, because here if I do 3 times 3 is 9, 9 plus 9 is 18, so that's good. So it's definitely 3. But now if I do -3, 3 times -3 is -9 plus -9 is 0. So I actually just figured out something here, because if I do 3 times -3 plus 9, I get 0. And then if I do a squared minus 9 and use -3 as well, I get 0. So 0, 0, 0 is equal to 0. which means I have an infinite amount of solutions. So here we have no solutions, here we have an infinite amount of solutions, and if we want many solutions, well, many solutions is just not -3 and not 3. So I'll just reiterate all of this. If I want no solutions, then A is equal to 3. Because if there are no solutions, it means that this row has zeros on this side and has an answer that's not 0. If I want infinite amount of solutions, then A is equal to -3. Because when it's -3, all of this is 0 and all of this is 0. And if I want one solution, so unique solution, A is not 3 and A is not -3.